Hey, we're going to integrate powers of trigonometric functions, and I say this because sometimes use substitution is not enough. We've integrated some in the past using use substitution, but what we're going to see now usually does not lend itself to use substitution. So let's see what we mean here. So we're going to have a couple different scenarios. They're all going to come from kind of the same place. Right now as we're starting out. We're starting out with integrals of sine to a power times cosine to a power. So I've got it written here as sine m of x, sine raised to the m of x times cosine raised to the n of x dx. And our first situation is going to focus on when m is odd, meaning when the sine power is odd. So if the sine power is odd, what we're going to do is we're going to separate one power of sine, and that's going to give us, since it was odd, when we take one out, the remaining will be even. Okay, and my example down here is I've got sine to the 7th. I'm going to pull 1 away, so just plain old sine times sine to the 6th. Okay, so I took 1 out. Okay. Then I'm going to rewrite the even power now, the sine to the 6th, as a bunch of sine squareds. So my sine to the 6th is now sine squared cube. Okay? So if you take a look at that, that's still sine to the 7th. There's the 1 sine out front, and there's 3 groups of 2. So that's 6 plus 1, so that's still 7. Okay? But the reason we want to do this is because when we get that sine squared, we can use the Pythagorean theorem, sine squared plus cosine squared equals 1. We can rework that, and we can replace the sine squared with 1 minus cosine squared. And this should lead us in a direction where we can integrate what we have. Now, we might end up having to use substitution along the way, and we might have to use some other trig identities. About anything could happen when we do this. Okay, so let's take a look. I've got 2 problems here. I don't know if they'll both make it into this video, but we're going to try and integrate sine cubed of x. So let's see here. So in this scenario, sine cubed, that is cubed. The m there is odd. Now there are no cosines, so cosine is raised to the 0. Okay, so it still fits the template here of sine raised to a power, cosine raised to a power. It's just that the cosine is raised to 0. That's why it's not written. So we've got sine cubed. So it's an odd power. So what we're going to do is we're going to come through and we're going to separate and make it sine of x times sine squared of x dx. Now, the nice thing about this one is that sine squared is already in the right form, sine squared. So maybe I'll pick up something a little bit higher in a moment. But what I can do from there is I can replace the sine squared with 1 minus cosine squared x. Okay? So what I'm going to do is I'm going to distribute this sine through. So I'll have the integral of sine x minus sine x times cosine squared of x dx. And I've got 2 separate things that I can work on here. I have the first one here, which is the integral of sine x. And everybody knows that the integral of sine x is, I don't need that. I need the eraser. Everybody knows that the integral of sine x is negative cosine x. Okay, but the other part, sine x cosine squared, and there's a negative in front of that, so we'll kind of sneak that negative down here when we do it. But that's a u substitution. We can let the u equal the cosine of x, then du will be negative sine x dx. So we're actually going to capture this negative over here. So when we replace this to do a u substitution, we'll have the integral of u squared du, because the negative sine dx will be replaced with du, and the cosine will be replaced with u. So that would give me 1/3 u cubed. But we know u was cosine. So as I come down here, okay, so I put this negative out here, but it doesn't need to be here because it got swallowed up in this situation. So let's just make sure we see it there. So we'll have 1/3 cosine cubed of x, and that'll be plus c. Now this is a cosine, this is a cosine cubed, so they don't interact, but we have fixed this situation. Okay, so we have the integral of sine cubed. Okay, we're going to do another example here. It is the integral of sine to the 5th x times cosine squared x dx. So it follows the same template as before, where the m exponent, the one on the sine, is odd. Okay, it's 5. Okay, so what we're going to do is we're going to come through here and we're going to separate, and we're going to take a single sine to the side, which will leave me sine to the 4th x times cosine squared x. And then I'm going to rewrite that sine to the 4th as sine squared squared times cosine squared. And then I will replace the sine squared with 1 minus cosine squared. And that's still squared cosine squared x. So that got pretty intense pretty quick. Okay, but just right there you can see that I've followed the logic of what I said. Okay, I had an odd number of sines. I separated one of them, which left me with an even number of sines. So I rewrote this to the 4th power as some squares raised to a power. Okay, so sine squared squared. Then I replaced those sine squareds using the Pythagorean theorem with 1 minus cosine squared. So I'm going to write that over here, and then we're going to try and follow through, because we don't really need the template anymore because we've done what it asked us to. So we've got sine x times 1 minus cosine squared of x squared times cosine squared of x dx. So let's see here. What can we do with this? Well, long story. Let's just go ahead and multiply things out. Okay, so we can either multiply all this out as it is, or we can start to look at the fact that we know that sine and cosine have a partnership in derivatives. So I think I can just jump right in here and do a u substitution. I can let u equal cosine of x. Okay, and if I do that, du will be negative sine of x, which means negative du will be sine x dx. So let's make some replacements there. We're going to call this the integral of negative du, replacing the sine dx with negative du, and then we will have 1 minus u squared squared. We're going to have to multiply that out sooner or later, but it's going to happen. And then times u squared. It's just going to be easier this way, instead of having to write everything over and over. So I'll let my u be my cosine and replace that. So unfortunately, we still got to do some algebra. We got this negative out front. Maybe it'd be better just to pull it way out front so it doesn't get lost. But then I need to square this 1 minus u squared. So that's a FOIL. 1 minus u squared minus u squared, so minus 2u squared. And then it's u squared squared, so that's plus u to the 4th. And all of that is times u squared du. It's a mess, but let's see here. If we distribute this u squared through, we've got negative integral of u squared minus 2u to the 4th plus u to the 6th du. Look at that. Okay, that is a sweet little polynomial that you can use reverse power rule on. So there's a negative out front. You'll get 1/3 u cubed minus 2/5 u to the 5th plus 1/7 u to the 7th. There'll be a plus c out here. I'm going to pause and make sure I haven't made a mistake. Okay with this? So I'm going to distribute my negative through and replace my u's back with cosine. So it'll be minus 1/3 cosine cubed of x plus, distributing that negative, 2/5 cosine to the 5th of x minus 1/7 cosine to the 7th x plus c. I know how you like to forget plus c. That is not the funnest problem, but I guarantee you it's not the worst one you're going to see going through this. Okay, it takes care, it takes time, it takes understanding of your goal. I could have gone through and left this as sine and cosine for a while. I would have got down to my last step on this row, and then I would have needed a u substitution. By going ahead and replacing it early on, if it works out, if I know what I'm doing, save a little bit of writing in there. Okay, good stuff.